Okay, so the organic in A2 is first of all, it's easier than A1. And as far as A1 is concerned, what do you need to memorize? What do you need to recall from that? The first thing, of course, is isomerism. Some basic definitions like hydrocarbons kya hote hain. Similarly, some mechanisms like substitution reaction, addition, and substitution. अब substitution तीन तरह की है, या the free radical substitution, या electrophilic, या nucleophilic. Similarly, the idea of where SN1 happens, where SN2 happens, uh, and then addition reaction, that the pi electrons are delocalized, like relatively delocalized, which makes them very reactive, and which makes alkenes, for example, they have a pi cloud around them, and that cloud attracts positive or slightly positive charges, and it pulls on them, and that way they do the addition reaction. Those are a few things from AS जो मैं साथ साथ आपको याद कराता जाऊंगा, और वो चीजें आपको यहाँ आनी चाहिए. सो अगर आप एल्कीन को याद करो तो एल्कीन का स्ट्रक्चर ऐसे था कि आपके पास दिस अ बेसिक ethene का स्ट्रक्चर, एंड द pi cloud is over here, and there's the sigma bond, so it's kind of like sandwiched between them, and the pi cloud is delocalized, and it forms from the p like p orbital. Obviously वो p orbital यहाँ पे hybridization के through sp2 बन चुका है, but the pi cloud is still from the p orbital. So sp2 से ये और ये बना है, but the p orbital is still forming the pi cloud. So that is something you should remember, that it's not the hybrid orbital that makes the pi bond. They always make the sigma bond. Okay. Now these clouds, they are rich in negative charges or slightly negative charges. So for example, when bromine came in, they created dipoles on it. So this was slightly positive, this was slightly negative, and then they attacked it, which made the electron go here. And that is how you end up with carbon reacting with one bromine and the other one getting a carbocation. And that carbocation was then, obviously, there was a nucleophile made, and this nucleophile then attacked carbocation, giving you dibromoethane. So that is how this all came out to be. And the reason was the delocalization and the strong reactivity of the pi cloud. Now we are going to move on to arenes. The simplest arene is benzene. Benzene has the formula C6H6. And the structure that we have so far is that there are 6 carbons making a cyclic compound. So there is 6 carbons in there. But these 6 carbons, like they're arranged like this. But all 6 of them also have pi clouds. And these pi clouds share electrons with each other, and they're all sharing these double bonds with each other. And these double bonds are going around the whole thing. So one idea was that maybe the double bonds are with this one for some time. So जब इन दोनों के बीच में, तो फिर इन दोनों के बीच में और इन दोनों के बीच में, और फिर जब इन दोनों के बीच में, तो इन दोनों और इन दोनों के बीच में. So kind of like saying that the double bond resonates. So the double bond goes like, you have this here, here, and here, and then it resonates. So it goes here, here, and here, and that is how the benzene ring forms. But if you do practical measurement of the bonds, then turns out that because of these resonance, ये नहीं है कि ये single bond है तो ये longer है और ये double bond है तो ये shorter है, which is usually the case. Like even in alkenes, if you notice, the double bond is always smaller than the single bonds between carbon and carbon. But that's not the case here. In everywhere you have resonance, remember this thing, resonance जहां भी आएगी, वहां पर bond length, bond energy, सब कुछ एक बराबर होगा. Bond angles तक एक बराबर होंगे. In this case, the angle is 120. So we say that this pi cloud, which is going around and around, it's actually delocalized. and we show it as a circle. So what's benzene? Benzene is a hexane. Sorry, ये क्या हो गया? Circular क्यों बन गया? Yeah, and then there is the ring that of delocalized electrons inside. So this is the benzene skeletal formula. ये ring क्या है? This is pi electrons that are forming around. All of these bonds are equal length, equal angle, equal energy, and uh, the ring in here, it is highly stable, very stable, जिसका मतलब है कि ये normal addition reactions नहीं करेगा. Benzene is pretty unreactive, and that is weird because it has a lot of delocalized electrons. Why is it unreactive, or why is it so stable? We will talk about it. But for now, just remember there is pi electrons that are delocalized, and there's 6 electrons, 6 carbons forming this. So ये हमारा skeletal formula हो गया. How do we name these things? We are pretty liberal with the names. So there are 2 words that we use. Sometimes we use the word benz, and sometimes we use the word fen. I don't know of a particular reason कि कहाँ पर fen होता है और कहाँ पे benz होता है. मतलब it's pretty random if you ask me. So I'll give you some examples. For example, if I have this thing and this chlorine here, this is called chlorobenzene. So chlorobenzene, that's what it's called. But if I have this same thing with OH here, this is called phenol. OH, so ol, and fen for showing the ring there. Similarly, if I have this benzene attached to nitro, this is a nitro group, तो इसको हम nitrobenzene बोल देते हैं. But if I have benzene attached to, let's say, NH2, so this is called phenylamine. So one possible trend that you can see is that when benz is used, it's at the end of the name, and when fen is used, it's at the start of the name. ये आपको लगेगा कि ऐसा है. And let me prove you wrong. Because when you have this thing attached to COOH, it's called benzoic acid. So I guess somebody just decided, some boomer, ke ye naam hoga. And that's what we have. I don't know of a particular reason why one is fen and one is benz. Maybe it sounds good. Maybe. Similarly, there are some other compounds. So there is, you can have this thing with CHO group, aldehyde group. So this is called benzaldehyde. So benzaldehyde. Similarly, you can have this group. This might be new for you. C double bond O and then chlorine. This is called benz oil chloride. Okay, benzoyl chloride. In fact, these compounds which have these, they're called acyl chloride. Similarly, just like OH is alcohol, SH, sulfur is also in group 6. It is thiol. So sulfur in place of H, they have very similar properties. This one is called thiophenol. मतलब अगर CH3 के साथ SH लग जाए तो उसको हम thiol बोलते हैं. But this one is called thiophenol. So some ways that we see this. Now here's the thing. जहां पर भी ये लगा होगा ना ये functional group, that will be considered the first carbon. And when we name them, we have some order in terms of कि हम किसको branch consider करेंगे और किसको main functional group consider करेंगे. So here's how it goes. If you have COOH, तो वो सबसे पहले आप उसे consider करोगे. तो अगर COOH है और OH है तो फिर आप OH को ब्रांच कंसिडर करोगे और COOH को मेन ग्रुप कंसिडर करोगे। अगर आपके पास एल्काइल है यानी कि CH3 C2H5 उसको आप OH के बाद कंसिडर करोगे। सिमिलरली X यानी कि क्लोरीन ब्रोमीन आयोडीन उनको इसके भी बाद और फिर NO2। सो मतलब दिस इज द ऑर्डर। सो फॉर एग्जांपल इफ आई हैव this thing here and there is OH here and a CH3 here, then here's what I'll name it. When in presence of OH, CH3 की precedence नीचे होती है, so it will be phenol because of OH being there with the ring. So this part is considered first, and then there is methyl. So this is 2-methyl phenol. Automatically OH considered to be on the first carbon. But let me add COOH here. Now this is the first carbon. So this will be second, third, fourth. Why is this second? Because इधर से आऊंगा तो बड़े number होंगे, इधर से आऊंगा छोटे number होंगे. We always consider the smaller numbers. So this one's now benzoic acid. And that means this is the first carbon. So it will be 4-hydroxy 3-methyl benzoic acid. How do you name them? Hydroxy and methyl should be arranged in alphabetical order. But हम लोग A levels में AS में इतना फर्क नहीं करते. So you can name one first and the other later. That's fine. Can you name this substance? What is this? Knowing this order.
Is it 2-bromophenol?
Yes. Shabash. So because OH has a higher precedence, so OH is making this thing phenol, and then the bromine is on the second carbon. Okay, how about this?
2,4-bromophenol.
Yeah, still phenol, but 2,4-dibromophenol. Okay, now let's do something else. How about this? Benzoic acid, right? But let me just shift this a little. Let's do this. And now we will consider this to be the main branch and this to be the branch. This is the main chain and this is the branch. So now this will be more like CH2COOH joined with some benzene. So we'll call it ethanoic acid joined with phenol, fen, so phenyl ethanoic acid. Let's try one more. Let's say, how would we name this? Again, we will consider this to be the main chain and these to be branches. So we'll just say there is ethene, there is chlorine on it, so chloroethene, and on the second carbon we have phenyls, so 2,2-diphenyl chloroethene. I've considered this to be the first and this to be the second carbon.
Sir?
Yeah.
Sir, what if is benzene की वजह से functional group पर?
So उसमें we will consider the placement of where that functional group is, और उसको हम यूज करते हैं 3 लेटर से, ऑर्थो, पैरा और मेटा. तो अगर यहाँ पे होगा तो उसको ऑर्थो कुछ बोलेंगे, अगर यहाँ पे होगा तो उसको पैरा बोलेंगे, और अगर उसके बिल्कुल सामने होगा यहाँ पे तो उसको मेटा बोलेंगे, और इन लेटर्स को साथ लगाएंगे ताकि हमें पता लगे कि उसके ऊपर ब्रांच कहाँ पे. ठीक है. So for example, अगर मेरे पास यहाँ होता chlorine. Now there are 2 ways of doing this. One is I say that I have 2-phenyl, 2 क्लोरो फिनाइल क्लोरो इथीन। एक ये तरीका है मेरे पास, ठीक है। लेकिन इसमें मुझे ये कंफर्म नहीं हो रहा कि क्लोरोफिनोल में क्लोरीन कहां पे है। सो इसको हम कह सकते हैं ऑर्थोक्लोरोफिनोल फिनाइल, सॉरी, या फिर जस्ट फॉर सिंप्लिसिटी वी कैन से 2-chlorophenol. So 2 then bracket 2-chlorophenyl chloroethene. Make sense?
So the benzene will still be like a branch, like it won't be the main
Yes.
chain.
Yeah, it won't be. Okay. So that is how you name them. Any questions? Okay. Now we'll get to the main chain, which is the main idea about reactivity. अच्छा, अब बेंजीन जो है या जो भी इसके सब्स्टिट्यूएंट्स होते हैं, they are usually colorless, they're oily, like oily in the sense कि उनकी smell oily होती है, and they are they do mix with non-polar solvents, but they don't mix with water. They are non-polar uh, because of only the London dispersion forces being there, Van der Waals forces हैं, and their boiling points are similar to cycloalkanes. So for example, जो हेक्सेन का boiling point होगा और जो बेंजीन का boiling point होगा, वो similar होगा काफी ज्यादा, because उनके अंदर इलेक्ट्रॉन्स एक जितने होंगे तकरीबन. Okay, so those are some basic ideas. They are usually liquids or solids, gases नहीं होते वो. ठीक है, ये इनकी होगी फिजिकल प्रॉपर्टीज. केमिकल रिएक्टिविटी इनकी कैसी होती है? हम पहले एल्कीन्स को एक दफा देखते हैं. मैंने आपको एल्कीन्स का भी सारा प्रोसेस बताया था, दैट द पाई क्लाउड वाज अटैकिंग and then a carbocation was made, and then on the carbon cation नया कुछ भी नया जो भी न्यूक्लियोफाइल है वो आ जाता था. Now these are going to react in a different fashion. मतलब अगर मैं आपको इलस्ट्रेट करूं, सो ये किस तरह से कर रहा था कि आपके पास अगर ब्रोमीन आ रहा है, सो सबसे पहले तो इसने उसको अटैक करना है, जिसकी वजह से यहाँ पे स्लाइड पॉजिटिव और स्लाइड नेगेटिव चार्जेस भी हैं, और ये इलेक्ट्रॉन्स इसकी तरफ चले जाने, जिसकी वजह से you will get a bromine added here, the bond breaks down, and the hydrogen is here with a carbocation. This is a nucleophile there, and that nucleophile then attacks the carbocation, leaving us with this thing. ये अभी मैंने आपको example करवाई थी. How is this situation different? Here's the thing. First of all, a slight positive charge is not something benzene is interested in. It's not. You need strong electrophiles to come in and attack it. पहली बात तो ये होगी कि electrophile में, even though you can have slight positive charges, or even sometimes electrophiles have like उन पे अटैक हो जाता है empty orbital की वजह से with positive charges, they need a full positive charge, मतलब उसने इलेक्ट्रॉन लूज किया हो, and then it comes in. ये नहीं हो सकता कि ये बेंजीन उसको इलेक्ट्रोफाइल बनाए. यहां पे दिस क्रिएटेड एन इलेक्ट्रोफाइल, इसको क्रिएट किया गया उसके इंड्यूस्ड डाइपोल की वजह से, और उसके बाद नया न्यूक्लियोफाइल बना. ऑब्वियसली जहां भी इलेक्ट्रोफाइल बनेगा न्यूक्लियोफाइल ऑटोमेटिकली बनता है, वो न्यूक्लियोफाइल बाद में अटैक कर रहा है. दैट इज नॉट द केस हियर. दिस वन इज न्यूक्लियोफिलिक electrophilic addition. This one is electrophilic addition for alkenes. Benzene will not do it. Benzene will do electrophilic substitution. कैसे? Benzene will wait for a full electrophile to first form. कहीं से इलेक्ट्रोफाइल आना चाहिए. ये इलेक्ट्रोफाइल बनाएगी नहीं, ये वो मेहनत नहीं करेगी. You must bring an electrophile first. अब इस पे ये बेंजीन रिंग अटैक करेगा. When the benzene ring attacks it, अटैक होता क्या है? दो इलेक्ट्रॉन्स रिमूव होते हैं और जाके दूसरे के साथ बॉन्ड बना देते हैं। ये होता है अटैक। दो इलेक्ट्रॉन्स लोन पेयर बनता है, बॉन्ड पेयर में कन्वर्ट हो जाता है, इसको बोलते हैं अटैक। सो बेसिकली यहां पे इस कार्बन ने, यहां पे 6 इलेक्ट्रॉन्स थे ना, उनमें से 2 को पकड़ा और इसके साथ बॉन्ड बना दी। यही तो अटैक होता है। अब जरा बताओ, अगर ये कार्बन था, इसने अपने कितने इलेक्ट्रॉन दिए हुए थे रिंग में? 6 इलेक्ट्रॉन है टोटल, 6 कार्बन है टोटल, तो हर कार्बन ने एक एक इलेक्ट्रॉन दिया हुआ है। ऑल दिस कार्बन डिड was it took one of its own electrons and one more electron, क्योंकि 2 इलेक्ट्रॉन का अटैक हो रहा है ये। द कर्ली एरो ऑलवेज शोज 2 इलेक्ट्रॉन्स। सो 2 इलेक्ट्रॉन्स यहां से उठ के उसने इसके साथ शेयर कर दी, मतलब उसने ये जो बॉन्ड बनाई है, इस बॉन्ड में एक इलेक्ट्रॉन उसका अपना था और एक उसने रिंग में से छीना है किसी और कार्बन का। डीलोकलाइज था ना, उसने पकड़ के बॉन्ड बना दिए। अच्छा, जिसका मतलब है कि देयर इज अ डेफिसिट ऑफ 1 इलेक्ट्रॉन है। ये बड़ा एक इंपॉर्टेंट पॉइंट है कि इवन दो 2 इलेक्ट्रॉन्स आर यूज्ड टू मेक बॉन्ड, ओनली 1 इज बीइंग रिमूव्ड, क्योंकि दूसरा तो उसका अपना ही था ना जो उसने शेयर किया। इन अदर वर्ड्स द चार्ज ऑन दिस हैज ट्रांसफर्ड है। ठीक है। अच्छा, इस कार्बन की दूसरी बॉन्ड हाइड्रोजन के साथ पहले से एग्जिस्ट करती है। तो बड़ी सिंपल सी बात है, अगर इसके पॉजिटिव चार्ज को एक लोन पेयर मिल सकता है, और ये बाय द वे लोन पेयर नहीं था, ये डीलोकलाइज्ड इलेक्ट्रॉन से बॉन्ड बनी हुई थी, तो इस पॉजिटिव चार्ज को नहीं मिल सकता। क्यों नहीं मिलेगा? इसको भी मिलेगा। सो दैट इज व्हाई दिस कम्स हियर। एंड व्हाट हैपेंस नाउ, just like this carbon broke the bond with carbon and redirected, बेसिकली उसकी बॉन्ड मैं आपको समझाता हूं कैसे थी। उसकी बॉन्ड थी इस कार्बन के साथ, और अब उसने उसको रीडायरेक्ट करके इसके साथ बना दिया। तो जो उसकी बॉन्ड हाइड्रोजन के साथ बनी हुई थी, उसको उसने रीडायरेक्ट करके वापस रिंग में बना दिया, या उसी एटम के साथ दोबारा बना दिया। सो काइंड ऑफ लाइक initially it had a bond like this with one carbon and one with the hydrogen, and when it saw a positive charge, उससे रहा नहीं गया, उसने उसके साथ वो बॉन्ड क्रिएट की, बट उसकी वजह से यहां पर एक पॉजिटिव चार्ज क्रिएट हुआ, और इस पॉजिटिव चार्ज को डिसवेड करने के लिए इसने ये हाइड्रोजन वाली बॉन्ड पकड़ के उसके साथ बना दी। सो हाइड्रोजन गॉन, इट हैज लॉस्ट एन इलेक्ट्रॉन, सो दैट इज व्हाट हैपेंस।
So like shouldn't the arrow be like was single wala, not like the double?
देयर इज ऑलवेज 2 इलेक्ट्रॉन्स कमिंग इन। इस बॉन्ड में 2 इलेक्ट्रॉन थे, इस बॉन्ड के भी 2 इलेक्ट्रॉन थे, जो इस बॉन्ड के 2 इलेक्ट्रॉन पकड़ के उसने इसके साथ शेयर कर दी, तो इस
So
बॉन्ड
but
के भी 2 इलेक्ट्रॉन पकड़ के उसने इसके साथ शेयर कर दी।
isn't hydrogen giving one electron?
हाइड्रोजन तो एक दे रहा है, लेकिन कार्बन अपना भी तो एक लेके आ रहा है। इट्स अ बॉन्ड पेयर दैट इज बीइंग गिवन।
Okay, thank you.
सो नाउ द रिंग is reinstated. And what about hydrogen? It goes away with the charge. So kind of like charge traveled from here to ring to hydrogen. And that point is super important. अगर आपको ये ज़हन में है ना, तो आपका मैकेनिज्म गलत हो ही नहीं सकता। ठीक है? चार्ज हमेशा सब्स्टिट्यूशन में ट्रैवल करेगा थ्रू द रिंग। सो पॉजिटिव टू रिंग टू हाइड्रोजन, दैट इज हाउ इट गोज। ये मैकेनिज्म है इलेक्ट्रोफिलिक सब्स्टिट्यूशन का। तो अब जरा ट्राई करते हैं। लेट्स से मेरा न्यूक्लियोफाइल है, सॉरी इलेक्ट्रोफाइल है मेरे पास नाइट्रो ग्रुप। सो कैन यू ट्राई एंड मेक द डायग्राम? Okay, I've received 2 results which are good. Here's how it goes. The intermediate बनने से पहले you obviously have to attack this. Now in the intermediate the charge must travel to the ring. This hydrogen's bond is shared here. So now you're left with nitrobenzene plus hydrogen ion. Okay, let's try one more. I want to end up with this thing. Please complete this diagram. Okay, so this one would be obviously you have an intermediate, you can work backwards. So in the intermediate, you have a partial ring, there is COCl, and there's the H. This gives the electron here. और उससे पहले क्या हुआ होगा क्या आपके पास ये था और COCl था और उस पर पॉजिटिव चार्ज था जिस पे अटैक हुआ. Okay, now I'm going to give you a final product. I want you to draw the 3 steps. दो दूंगा. एक ये है, ये आसान है. Okay, ये वाला आसान है. Try this one, and if you're done, then try this one. Right. So, any luck with this? क्या होना चाहिए? What is our electrophile? First, identify that. Come on, people. बताएं. What was our electrophile when we ended up with this? It was, of course, anything that is attached to the benzene ring. So it must have been this. It's that simple. जो भी चीज आके substitute हुई है, वो खुद ही electrophile थी. This attacks this, gives us an intermediate. In the intermediate, you have half ring. This is attached to this one. The charge moves to the ring. And hydrogen here. And this then goes here. ठीक है, so curly arrows आपके बिल्कुल ठीक होने चाहिए. They should show the movement of electrons. And that is how we are left out with H positive ion. Let's come to this. Does everybody understand कि क्या हो रहा है? Whatever is attached to the ring must have been an electrophile once. And this is how they are attacked. अब इसको देखें. Electrophile क्या था? Just identify that.
Sir, the carbon double bonded O.
Just that?
And the benzene ring also.
And the
that was
benzene ring,
attached.
yes. Because if you consider this benzene, then this whole thing, whatever is attached, must have been an electrophile once. So you must have started off with the benzene ring and then CO and then another benzene with this, with a positive charge here. So this must have attacked, creating intermediate. And then this. Do you see ke wohi cheez hai? Whatever is attached should have been there. Of course, you can then argue that how did this come over here? How did we create this electrophile? And that's the next question. How do we create these electrophiles? You can't just find them naturally moving around randomly zameen se utha ke kar diya. Aise nahi hota. There are some ways to create this electrophile, whatever we have. And that's
Do
the
we
next
use the
step.
catalyst?
Yeah, we use a catalyst because we need to somehow break the bond heterolytically. And catalysts usually help us in doing that. So here's how we generate most of the electrophiles. Most of the electrophiles, not all of them. Okay. So the simplest method that we have is by using a catalyst like AlCl3, BF3, AlBr3. Okay. These are some catalysts that we use all the time. If you don't use BF3, then you can also use FeCl3 or FeBr3. Wait a minute, FeBr3, yeah, that will work, yes. Okay, so these catalysts, what is an important thing? Why does aluminum trichloride work? Because aluminum trichloride has an empty orbital. It needs to make a dative bond to complete its octet. And dative bond needs to bring in 2 electrons. So we need something that has high electronegativity so that it can basically pull on the electrons. And second, it is interested in making a dative bond. It has lone pairs. So what better thing to do that than chlorine? So here's what we can do. Let's say I want to create an electrophile CH3. मुझे ये चाहिए. So I will react it with chlorine. So I will come up with CH3Cl. Obviously, to do that, I will need to do free radical substitution of methane. That is one way of producing it. Not the only way, but one way. So here's what's going to happen. Chlorine has a dative, has lone pair. It can share this lone pair with aluminum. And that way, it can create AlCl4 with a negative charge. Hua kya? Basically, when chlorine does that, chlorine also pulls on this bond pair and breaks free. So chlorine is able to make a dative bond with this, but at the same time, chlorine is going to break that other bond heterolytically. So we are left with CH3 with a positive charge and chlorine with a negative charge, making a dative bond with aluminum trichloride. And of course, the negative charge is distributed because once a dative bond is made, everything is identical. There's nobody can say that, oh, this was the chlorine that came in. It could have been this, it could have been this, it could have been this. So negative charge gets distributed. So as I told you, you always make electrophile and nucleophile at the same time. And there you go, we made it. We have created an electrophile. And of course, we have created a nucleophile. Okay, now this electrophile can go in there and do what we
Sir?
already see. Yes,
CH3 is the nucleophile.
CH3 is the nucleophile. It all comes down to मुझे कौन सा nucleophile create करना है. अब जरा देखते हैं इस रिएक्शन में मुझे कौन सा न्यूक्लियोफाइल क्रिएट करना था. ब्रोमीन. तो हो सकता है कि मैंने इसका रिएक्शन इस तरह से कराया हो. मैंने Br मॉलिक्यूल लिया, उसको मे बी मैंने FeBr3 के साथ रिएक्ट कराया और इसके डेटिव बॉन्ड इसके साथ बनाई और ये इलेक्ट्रॉन से छीन लिए. That way, I ended up with FeBr4 with a negative charge plus Br with a positive charge. And then I took this Br positive and reacted it with this. अच्छा मुझे बताएं, मैंने नाइट्रो बनाना है. अच्छा नाइट्रो बाद में बताता हूँ. मैंने ये बनाना है, बताएं मैं कैसे बनाऊंगा. अगर मुझे ये इलेक्ट्रोफाइल बनाना है तो मैंने कैसे बनाया होगा. बहुत आसान है. I will take whatever electrophile I wanted to make. COCl था ना, not cobalt, COCl with a positive charge था. तो that clearly shows कि यहाँ पे कहीं पे कार्बन के साथ कोई चीज ऐसी लगी हुई थी जो कि dative bond बना सकती है. तो maybe another chlorine, and that maybe I reacted with AlCl3 या Br3 Cl कर लेते हैं. अच्छा, अब इसके पास है लोन पेयर्स. इन लोन पेयर से मैंने इसको बनाई डेटिव बॉन्ड और इससे इलेक्ट्रॉन छीन लिए. एंड दैट वे वी एंडेड अप विथ AlCl4 with a negative charge and this with a positive charge. Electrophile created. This electrophile I will react with this and do whatever I want. So go on. Tell me how I created this electrophile.
We can make the fourth bond of the carbon with chlorine, and then we can use AlCl3.
Excellent. We can certainly do that. Yes. How about this? Same idea, right?
Yeah, or we could use like AlBr3 too.
We could, yeah. Shabash. Now, so the first step was creating the electrophile. Sure, we can create electrophile using aluminum trichloride or FeCl3 and all that. There is another way of creating these electrophiles. That is for a particular electrophile, nitro. Nitric acid is a very interesting molecule. Did you know nitric acid has a ionic bond in there? Like it has charges in it. Nitric acid का formula ये होता है. Yeah. This is nitric acid. NaS. Now, nitric acid can split in two ways, depending on the conditions. Nitric acid can, obviously, if you dissolve it in water, it can produce H positive and nitrate ion. Or in the right conditions, especially the one where you have concentrated sulfuric acid and low temperature, like less than 55 degrees Celsius, it can break down and give us nitro plus OH minus. It acts like an alkali. That's such an interesting thing. A very strong acid acting like an alkali. So you can get this. And of course, in here, the nitro group is like this. Nitrogen with 4 bonds and a positive charge. Again, such an interesting substance. So the nitro group has a positive charge. It's an electrophile. It can go and attack this. So that is how you can easily create this. The exact mechanism of how nitro group attacks it and what exactly does it do, we don't need to know that. Just know that in presence of sulfuric acid, nitro group can react and make split up into OH minus and nitro. Nitric acid can split up into that. And then OH minus can react with the sulfuric acid to make water. ठीक है?
Sir,
Yeah.
oh, what's the difference between nucleophile and electrophile?
So that's a very good question, actually. Electrophile obviously is something that is attracted to a negative charge. So what do they usually have? They have a full positive charge. They have a slightly positive charge. And in some cases, in fact, in all cases, they have an empty orbital. So using that empty orbital, they can pull on a dative bond, make a dative bond. All electrophiles make a dative bond. That's important to remember. Because obviously उनके पास positive charge होता है, तो उसकी वजह से उनको 2 इलेक्ट्रॉन चाहिए होते हैं. अच्छा. Nucleophile is anything that has a negative charge, which means nucleophile can attack an empty orbital itself. अब न्यूक्लियोफाइल जो है उसके ऊपर नेगेटिव चार्ज होता है क्योंकि उसके पास एक एक्स्ट्रा इलेक्ट्रॉन होता है या उसके पास लोन पेयर होता है या उसके पास स्लाइटली नेगेटिव चार्ज होता है. सो नेगेटिव चार्ज और लोन पेयर दोनों, मतलब न्यूक्लियोफाइल जो है वो न्यूट्रल हो सकता है फॉर अ टाइम बीइंग, मतलब उसके बाद लोन पेयर है उसके अटैक कर दिया. बट इलेक्ट्रोफाइल जो है वो पॉजिटिव चार्ज या स्लाइट पॉजिटिव चार्ज होगा तो अटैक करेगा. ठीक है. सो दैट्स one difference in them. Does that answer your question? या और confused हो गए हो?
Oh, no, yep. Sir, so basically, ऊपर you drew like CH3 or plus, so that's an electrophile, right?
That's an electrophile. Yes, it has a positive charge.
Okay, take it.
Okay, so now we know that this is how they are going to do. So हमारे पास benzene से जो भी हम बनाते हैं, we need two things. First of all, we know that the ring is very stable and will not attack partial charges. It will attack full charges. यानी कि strong electrophiles के साथ reaction करेगा. Which means we need to create strong electrophiles. To do that, we have two methods that we have seen so far. One is using these catalysts, dative bonds, and then they make this. And then, of course, they do substitution. ये substitution हमने देखी कि they do this substitution. Of course, the reaction ends when this H, जो हर जगह पे बन रहा है, it goes back to this thing and creates HCl and regenerates the catalyst. Let me give you one example. कि अगर मेरे पास AlCl4 था, तो वो H positive आता है और HCl plus AlCl3 बना देता है. That is why whenever we are trying to create HCl, we don't use AlBr3. क्यों भला? क्योंकि in presence of AlBr3 and Cl, H positive can create HBr or it can create HCl. So it can mess up our catalyst. क्योंकि अब वो अगर HBr उसने बना दिया ना तो हमारे पास AlBr2Cl बन जाना है. And that has messed up our catalyst. So that is why if you are going to make HCl, you always use AlCl3, and if you're going to make HBr, you always use AlBr3. Yeah, FeBr3. Okay? So the H positive, the electrophile that is generated, goes and makes an acid. So the catalyst is regenerated in all of these processes. The second method of making the electrophile was by making nitro group from the nitric acid. And that's it. That is the main reaction of benzene. एक खाली reaction जो last रह गया, that is when you do hydrogenation. So hydrogenation is you take the benzene and you add lots of hydrogen in presence of nickel catalyst at high temperature, usually 300 degrees Celsius, and that creates cyclohexane and the ring goes away. Okay, so that is it. We have made the benzene K reactions.
Sir,
Yes.
are all benzene reactions electrophilic substitution?
No, this one hydrogenation is addition reaction. ठीक है, फिर बेंजीन के साथ जो चीज आपने अटैच की है ना, मतलब फॉर एग्जांपल ये चीज आपने अटैच कर दी है या आपने नाइट्रो बेंजीन बना दी है या ये एसाइल क्लोराइड बना गया, इसके अपने भी तो रिएक्शंस होंगे. ये जो ब्रांच अब आई है ये भी तो अपनी कुछ प्रॉपर्टीज लेके आएगी. वी विल स्टडी दोस. अगले 3 चैप्टर्स यही हैं कि बेंजीन के साथ अगर एसाइल क्लोराइड बनाया हमने तो फिर वो कैसे बिहेव करेगा, नाइट्रो लगाया तो वो कैसे बिहेव करेगा, OH लगाया तो वो कैसे बिहेव करेगा.
So I'm a little confused. Didn't you say कि like electrophilic addition benzene में नहीं होती?
नहीं इलेक्ट्रोफिलिक एडिशन नहीं बोली मैंने, वो नहीं होती. यू राइट, मैंने कहा है कि इलेक्ट्रोफिलिक सब्स्टिट्यूशन हो रही है या ये एक एडिशन है, हाइड्रोजन की एडिशन. ठीक है, और इसका मैकेनिज्म हमारे सिलेबस में वैसे नहीं है. लाइक हाउ डज हाइड्रोजन ऐड टू बेंजीन.
Okay, so basically electrophilic addition of benzene is not part of our syllabus. We just need to know कि ये हो रहा है.
या सो देखो, अगर रूम टेम्परेचर पे मैं करना भी चाहूंगा ना ये वाला रिएक्शन, ये होना भी नहीं. आई नीड दीज कंडीशन, दिस कैटलिस्ट टू हेल्प मी आउट विद मेकिंग श्योर दैट एडिशन हो जाए हाइड्रोजन की. ओके,
Yep, got it.
ऑलराइट.